Okay, Monica and Tejashwini, let's start with the life cycle of thread.
Okay, sir.
Yeah,
Yes, sir.
the life cycle of a thread. Okay, generally you can say it has the four states or five states. The five states of the life cycle means for but better understanding of the thread, we can just describe the life cycle in Java of the thread in five states. Five states. Those five states are first new. It means you need to create or you need to create or start the thread. Means the instance of the thread must be created first. Then you need to do it as a runnable. Then it has to be running. Then sometimes it can be your non-runnable. That is sometimes a deadlock or a block situation comes. And then you need to destroy your thread. That means you need to terminate it, terminate the execution of the thread. Uh, so these are the five states, starting with the new, then it's runnable, then running, then non-runnable, and then you need to terminate the thread. So a new means if the thread is a new means you need to means one need to create the instance of the thread class. I will explain you in the programs while doing the threads and all. What is this thread class or what is a runnable interface? How to implement all this? Then, after doing this, after instant, you need to make the thread as runnable. Just give me 2 minutes. We need to make it runnable. So when the thread is in runnable state means after the invocation of the method start, there is a method called start. Whenever you invoke the start, then the thread becomes in your runnable state. Then, but remember that is still not in running state. It has become a runnable state, but still it is not in your running state. Then, when it is your running state, means the thread scheduler has selected it. There are some schedulers, the thread schedulers in the JVM. Then they start running that running each and every thread. So a thread becomes a running. So in the 4, if it is called non-runnable, so you can say this is the state when the thread is still alive but is currently not eligible to run. This is your non-runnable state, maybe a deadlock situation. Then you need to terminate it. Terminate it means there is when the run method. We will check with the start or the run method. What are these? Exits. Then your thread becomes terminated. You cannot keep a live thread in your scheduler, so it will cause you a problem, or there will be a problem in the CPU that the state becomes infinite. So there will be means overhead for your JVM or the CPU in the performances. So let's go thread programs. Now remember one more thing in Java. Whenever I'm writing this main class or doing anything like a general demo, what I've given, it has the main class. So this is one of the main thread of your program because it has only one thread. This program has only one thread, that is the main thread. Now um, we can see, we can check, there is a super class called thread. Thread is, suppose this is the super class of our thread. So this main or main class is the child of this particular called thread class. We can check this. If it is something, I'm writing here thread t equal to thread dot current thread, and suppose I'm just printing it out, this out, current thread. Let's check what it comes. See, it is already showing me the current thread is your main, that is the child thread. This this is the main thread, means main thread is the child thread of this class called thread. We can give the this main thread, we can just change the name also like this, set name. Suppose if I give my thread, then I give it something called current thread, or you check this now. See, it has come my thread. This particular thread is my thread now, the name of this particular instance. So this main is the child thread of our class, the main means of our class thread. So whenever you create a thread, you have two options. Whenever you want to create a thread, creating a thread, there are two ways to do it. Two ways to do it. One is you have called runnable interface. Whenever you have an interface, that means one needs to implement that interface. Second, the second way that you can do is by extending the thread class itself. Whenever it is a default, or remember we are doing it's automatically the child means child threads of that particular class thread. Even the main we have seen, this was the child uh, thread of the class thread. So we can explicitly also create a thread by extending the thread class, or you can means implement that interface, that is the runnable interface. Then you can start your thread. Means you can create your thread. So creating a thread, after you create a thread, you need to create the object that is called the new here. Means that is one need to create the instance of the thread class. We are creating this particular object of this particular called thread class using new, and then suppose your thread class was thread, maybe we can do, or we can do something new thread, anything you give it. So this is way we can start with this. Now whenever you implement the runnable interface, uh, or the thread class, you are extending a thread class, you need to call this method called run. Inside this, inside this, one write a block of code or the implementation of the thread that one is intending to do. Since your main thread, if you are doing a multi-threading program, you should write run, and there you must give uh, a particular call the in the method run. You need to write your own implementation to start this run. To start this, to invoke this run, you need to invoke the method called start. Just invoke it. It will start your thread. Let's do by this first, the runnable interface, then we will check with that, uh, check with particular thread class. Let's do a program, create a package called thread examples. Suppose my class is your new thread. I'm implementing the runnable interface. See, I need to override the method run that already that is present inside this runnable interface. This is already present. We need to write my block of code in this particular run for the thread. So before that, let me create the object of the class thread. Just refer it. Now let me do a constructor of this particular class new thread. Here create a new or maybe a second thread here. Suppose t equal to new thread. I'm creating a thread here in this. Whenever you this thread, remember this particular thread can take your object, like you need to pass. See, whenever I'm doing a thread and the constructor of it is public thread, then you have the runnable target. That means the runnable, the instance, and you can give the name of your thread. Suppose this means it is the current object of this class. I am just passing in the runnable target. You can check this is the runnable target, and this is the string name that I'm giving as demo thread. Suppose I'm giving system. This is my actually the child thread that I'm creating. Child thread. My void main is the main thread already, and then I'm creating a child thread again. Okay, I will write the void main in another class. That is my main, what you can say, the main thread. And this after the main thread, I'm also creating a new thread here. That is the child thread. Then I'm starting this particular call t.start. This will start the thread. Now, starting the thread means this is the entry point, if I can say. This is the entry point for the second thread. So whenever I do t.start, it will invoke automatically, means it will start the thread, and the entry point of the start thread after doing t.start is my void run. So let me write my block of code. Maybe I want to print something. Suppose try catch interrupted exception. Mistake here. Okay, I need to write interruption here. System. Let me write something. Say a simple for loop for int I is equal to 5 when I is greater than 0. I am doing I minus minus. Then it's out. I'm doing a child thread plus I. Okay, let me do this thread sleep for 1000 milliseconds. I have finished with my thread. So this is the entry point of my second thread. Let me create the first, means the main thread. We have seen that main thread is the void main is a type of thread. That is my first thread, and the second thread I have already created here. So let me check, give it as thread demo. I'm going to have the public static void main. See, I'm going to have this public static void main, and this is my uh, thread. So here, what I am doing, I'm just creating the new thread, like new. It's suppose I'm here also. Same thing, I'm doing it here. It will be my main thread. This is my child thread that I have created. This is my main thread. Okay. Then we can also give it here. sysout thread exit, that is my terminated thread. Now, see, I haven't called this particular thread. To call this particular thread, I need to create an object of this particular new thread. So let me just create an object without referring anything. So I can directly write new. So what happens? I'm just invoking or creating the child thread here, creating the child thread or starting the child thread. Rather, it's say it's yeah, creating the thread. So you can check from this program, this your new I'm creating the child thread here. This is particularly your new that I am doing. Now I'm sending it to runnable state. So runnable state, I have done it in the whenever I do a new, that means this constructor is being called. This is my default. So whatever I do, I just start this t dot start is your runnable state. See, and then it becomes a running state. Running state is your public void run. Whenever I invoke this becomes runnable. Okay, it will say let's start the thread. Then it will enter automatically with this particular called run, which we have overridden. Actually, this is a method that is written inside runnable or the thread class. See, now uh, the run statement, here it is run. The run statement is actually running the thread. Run method, sorry, the run method is actually running the thread. So there can be a situation, there will be a deadlock while running the thread. Maybe in the void run I had implemented in such a way a mistake for which there was a deadlock, but the but it is not executing, but the thread is still alive, but it is not currently not eligible to run. That means it has been suspended or it has been blocked some way for my implementation of a code, and that has been stopped executing, but the thread is still alive. Whenever you finish this particular run statement, your thread is automatically gets terminated. So let's check with this. See, it is creating this. Remember, have you checked that after this, what I've given, thread.sleep 1000 means it will suspend the thread or it will wait for 1000 milliseconds. Thread.sleep means it will make the thread to sleep or to stop the execution for 1000 milliseconds. So 1000 milliseconds, I believe it is your 1 second. So if you give 500 milliseconds, is your 0.5 seconds. So I have made the thread to sleep for 1000 seconds. And remember this child thread or main thread, see the execution for in different CPU, depending on the speed of your CPU and the JVM, these results might differ. Maybe it is giving me this particular scenario. First it is main thread, then child thread 5, then again it is starting with the child thread 4, then it is main thread, then child thread, again the main thread has been started. This can be what I will say, a different result at the different computers. Maybe you are just writing this program, you can get a different result. If I had given 10, let's check. See, in this case, what happened for 10 seconds means I'm starting with the main thread. It has started. It is just sleeping for 10 milliseconds. But my child thread that has been started here, this child thread that has been started, it is sleeping for 1 second. So what happens before that 1 second? My main thread completes it. So the main thread exits. Then again my child thread gets execution. So is it clear? Any questions do you have?
No, sir.
Okay, okay. So now we have already seen, let's extend the thread. So this was my using my runnable interface. But if I had to extend it, if I had to extend this, let's create another. It will be something called new thread by end. See, now I'm extending extends thread. I'm extending the class thread. This is another way to do it. Now let me make the constructor. Let me call this super. You remember the super, and then I'm giving it something called demo thread. So it's initializing the means the instance variable of the thread with this called super statement, and I'm doing a sys out, give this child thread, and I'm printing this means the current object here. Then I'm directly starting it here, starting the thread. Start. See, for here you need to create this particular thread T. Then I'm going to do T dot start. But here what I am doing, I'm just writing directly. I'm just extending this thread. So now I am just overwriting the same run method that I had written in my new thread while implementing the runnable interface. So I'm just copying it. Let me check. Okay, I need to more. I'm doing this out here. I'm giving it here, exiting the child thread. Now I'm going to this demo thread here. Let me start this object in a similar way that I have implemented and started. Let me start this object and let it remain the same way that I had written. See, now I had started created the new thread by this object. See, let's give it 1,000 seconds. Check now. See, it's printing me in the similar way that has done it. So depending on CPU speed, this the output can be different. Now, if I had given something demo thread 2 here, child thread 1, and I had initialized this thread 2, something called new new thread. Now you check. I've created actually the 3 threads. Why it is not printed me? Thread 2. Let me check with this again. It is printing me this particular called thread 1, but it is not starting this particular thread. Let me check why. Because of the third method maybe. Okay, this child thread 1 I have given. I have differentiated. Now I will check. It's not letting me to see. It is printing main thread, the child thread 1, or the child thread 2 means one child thread and the main thread. So I have started here 3 threads along with 2 extra threads, 2 child threads along with my main thread. So you can just simultaneously do the execution of a thread program by either implementing your runnable interface or by extending the thread class. This is the way that we have to do. And and now there are 2 methods to check whether your method thread is still alive or not. We can check in this way. And suppose I had given something here. Here it is a child thread. Now, whenever I had mentioned an object here, suppose I've referred and done the object to check new equal to this new thread by extend object, and suppose here I had given new thread. This object is, let us check this. If I had given something like called is live, is live, then this out. this out means that new this class is my still alive, still alive. Let's check if this particular scenario is also, if it is still alive after exit. Let's check this program. See, first it has come new thread is still alive. That means this still alive method will check whether your thread is still processing or still alive. But here, whenever you come out particular this run, that means I told you this state is it is called terminated when the run method exits. So the thread gets terminated. It is not still alive. So it has not printed me here that after exit new thread is still alive. If I had given something a false, this statement will return me either true or false. True when the thread is still executing, hasn't got terminated, and false when the thread is already means it has stopped running, it has already got terminated. So let's check this. If I had given not equal to here, means if it was something, see, it has printed me this. After exit new set, it will not let me, is not alive, that is dead or terminated. So I could have run. See what happened here. What happened here? So executing the child thread, it is execute. See, this depends on my CPU computer. So first happened this that this main thread has got this has stopped executing and this particular my thread is still running. So it has printed me after this thread exit, the exiting the child thread. I told you that depending on the CPU computer, this results might different. So in this instance, my thread was still alive. So this particular called thread hack exit has been printed first, and after that, this particular thread has been printed. So even after this main thread has completed its work, this particular thread hasn't completed and it was still running. So let me check if I had given something thread.sleep as only 10. See, it will print me now. I'm sure it is going to print me. See, after the exit, my thread XA is not alive because this has already been completed as the sleep was very less. Now we have a method called join. We have since is alive method. Now we will see that particular join. Join this particular if you will use join method here means it allows you to wait means if you use a method called join that method waits until the thread on which it is called terminates. Let's do let's do a program and check what does it mean
Excuse me.
using this particular. Yeah, yeah.
Um, Once the main thread is executed, what about the
Yeah.
statements after the run method in the main thread? Are they
Main
executed?
thread, main thread, right? This is the main thread.
Yeah, the last if block.
Which one?
The
This?
last if block.
Yeah. See, it
Uh,
has executed, right?
no, the previous example which you have given.
This one?
Yeah, previously you have given 1,000, right?
Yeah.
The
See,
main
until
thread
and
is
unless, yeah, the main thread, until and unless, you can check this. Suppose if I had given 1,000 here, 1,000 here, and 10 seconds here. So the main thread, suppose you give it something. So this is, I'm just doing, or main thread, I'm completing it within seconds. Suppose not also 1,000, you give it as 1 second, means
yeah,
1 milliseconds.
only for 1 second. Yeah.
It's 1 milliseconds. Let's
Okay,
check.
1 millisecond.
Yeah, this is executing, right?
Okay.
Even the main thread has exit. See the thread exit. This is my main thread is already been stopped. My child threads were getting executed. Remember
Uh,
this each,
yeah,
yeah, each
but what
thread
about the
uh,
statement after that?
after this particular thread.
This statement will be executed.
See, if it was alive, yes, it will. See, it has. After the exit, this already been executed. Thread has already been executed. This has been
Okay.
finished with my main thread. This has already printed me this particular after the exit this new thread extent is not alive. This
Okay.
what I have given here, it is executing.
Okay.
Your main thread ends until and unless your all threads executes your all the programs. Each thread has a different execution path of execution of each thread are different. They are not dependent on each other, but your main thread will means stop until and unless all your thread has completed its work.
Yes, sir. Can you show me the uh,
Yeah,
execution, like the output once again?
yeah. See the thread main thread is this, then it is executing this.
Okay. Child thread is of runnable, right?
Child thread is my runnable means this. See, this is my child one, and this is your extends thread. Maybe if I had given it here, exit runnable thread, you write it here, and exit the new thread. So let's do. See,
Okay. So,
child thread was means that I have done, and runnable was my runnable this. My main thread has executed this, but remember the main class, the main will stop after all the threads has completed its work. So still it was printing me.
I think after exit new thread by extend is not alive. That statement should is wrong, I guess.
Which one? This.
Because the child thread is still alive, right?
Yeah, this child thread is still alive. So you can say this is the statement what I've given. This is printing me what I've written in this out.
Yeah, yeah, yeah.
So it is alive. Means it
Yes.
has printed me whatever I had written.
Yeah.
So
Okay.
it is
Okay.
alive. That's why it is printing me, right? I've given a condition is alive. So you
Okay. Okay.
got it. It
I
was
was thinking
printing.
you have put the negation. I'm sorry. Yeah.
No, 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 no. I haven't
Okay.
put a negation here. It is just
Okay.
passing me a true, and it is telling me it's not alive or something. If I had put a negation here, see, if I had put a negation, it won't print me this state.
Yes.
Check.
Yes. I got it. Yeah. Yes, sir.
See, it has not printed me after this thread exit.
Yeah. Oh. Oh. Okay. That was my mistake. I was thinking it was negation. Okay.
Okay, okay. Yeah,
Okay. Thank you.
okay. Yeah, so we were in the join statement. Just wait a minute. Give me a minute. I'm getting a call from office. So yeah, come on. I told the join method waits until the thread on which it terminates or dies. In other words, suppose let's do a program, then you will understand. Suppose suppose only let's do creating a thread here. Thread demo. I was creating this, and I am creating a thread again a child thread with the same object, and I'm I do not want this. This is thread one. So another child thread is being created. Another child thread is being created here. Okay, let me do this out to explain the join. Let me comment out. Let me do with a single class, like two objects of the same class I'm creating. That means two child threads are being created. This child threads, though they are the object of the same class, but the child they are different objects, so different path of execution for each thread will be created inside my memory. So this is one of the threads again of the same class. I'm creating a second thread. So if I had done this way, just this thing, let's check what would happen. See, it's creating 2 3 2 2 1 and exiting the child thread. If I had given something here called join, I need to write in a try catch block. See, if I had given here something called join, let's see what happens. Okay, so I'm starting it here both at the same time. Okay, both at the same time. So you are not reflecting anything. If I give 1,000 milliseconds here, let me do a program. this way we cannot do it. So let's do a different program because I am sure that I have written the start here. Yeah, if I had written the start instead of writing the start, if I had written it here, if I write it here, and then if I had written it here, start also, let's say I had given, I need to modify my program, otherwise you won't understand. Let me modify the program a bit. Let me take remember here at a mistake that I forgot to tell you, this super statement should always be the first statement when you are using this super. This super should be the first statement inside your constructor, otherwise it will give me an error. When I had written this something, it was showing me error because it was not the first statement. Now let me do this, and here let me create something called str1, str2. Let's this way and let's check. Make it more reliable or something called str. I'm also printing this to understand the difference. Now we understand the difference. Why it is giving me str? Sorry. Yeah. So now we can understand the difference when it is printing me for this and when it is printing me for particular this. This is your maybe str you can say, or suppose you say the first thread, and this is my second thread. Now when I'm doing a start here, let's check how it is printing me. See. Now let's do a program. Let's write here. Suppose I'm doing this. What happens? Let's check. And then I'm using this here. So whenever I used a join statement here, that means this is just waiting for this to complete its execution. Then it will start your execution of this particular thread. So the join statement, if I had written, if I had removed this particular part, you can see both of them are executing at the same time. It is not waiting to complete that particular. See, both of them are starting at the same time. Okay. So, now I'm using this try catch, and I'm using a join statement. So this particular thread is waiting for this to complete, then it is going to start its execution. Let's check. See, this first thread is completing first, and then my child thread is working. Means the first thread, the thread first, that which I've given first thread, is just when I've used a join, that means this particular thread is waiting for this particular thread to complete its execution. So you can say the method waits until the thread on which it is called terminates. So it is expecting it to check whether this is still alive or this is still dead. So see, suppose if I had given something, a negation here, suppose if I had given a negation here, whether this my first thread was still alive or not, I've given a negation now. Now you check. See, it has printed me. It's not still not alive. Then it is executing my next statements. So is it clear, Monica, Anusha, and Tejashwini?
Yes, sir.
Joint statement.
Yes, sir.
Okay. Okay.
Yeah.
So in the next class, we will do with your, this is called thread priorities. And also we will see the synchronize block in the thread, synchronize methods, blocks, you can say, and the statements and everything. Then we will see a deadlock situation. These three we will do. We will see a deadlock situation, and maybe how to resume the thread or suspend the thread. That also we will see you in this particular deadlock, resume or suspend. Okay, that's it for today. And if you have any questions, please ask me. Do you have any questions?
No, sir.
Okay, okay. Okay, bye and good night.
Bye, sir. Take care.
Okay.
Okay, sir. Thank you.
Yeah.